Hey Chem 20, so this is part 2 of our review class. In this review, we're going to be talking about molar mass, which is capital M. So let's even write that out, molar mass. And don't be lazy with this. Capital M is very different than lowercase m. So molar mass, capital M, and it is typically the units for it are grams per mole. So we'll do a bit of review for that. N, which is moles. Which is, I always find this funny. So N is the number of moles or the amount. And then what I find funny is the units for this are moles, M-O-L. They took the E off for some reason. So moles or amount. So two words that we should know. And then lowercase m, so very, very specifically lowercase m, we're talking about mass, which in chemistry we measure in grams. Perfect. So we'll review those three pieces and how we go back and forth between them. And then also a bit of rearranging equations and back to that unit conversions. Unit conversions is just going to be so important for this unit. So let's start with molar mass. So molar mass. So it is the mass of 1 mole of a substance, and that could be any substance, 1 mole of any substance. It's just we typically look at chemicals because, well, it's kind of ridiculous to look at anything else. I guess we should also talk about moles or amount. So moles are just, remember, moles are just a number. 6.02 times 10 to the power of 23 of anything, just like a dozen is 12 of anything. So when we look at it, we're looking at the mass of 1 mole, so 6.02 times 10 to the power of 23 of anything. So mass of a particular amount of something. As I go through, if we were to get out our data booklets, because again, for this particular one, we'll need calculator, scrap paper, data booklet, and we might start to, you might want to have your workbook out as well. Do I not have my data booklet open? Oh no, I got it open right here. Perfect. Perfect. I thought I had it. So as we go through, our molar masses, they're actually really easy. They can just be found on, for individual atoms, can be found on our periodic table. So for example, beryllium. 9.01 is the molar mass for beryllium. Lithium, 6.94. Titanium, 47.87. What about for iron? Yep, 55.85, way over here. So not too bad. For elements, it's right there. And what that really means, go back to the correct sheet, is for iron, it was 55.85 grams per mole. What that really means is 1 mole of iron has 55, or is the same thing as 55.85, oh no, I got that right. I'm screwing up like crazy here. 0.85 grams of iron. That's what it's telling us. 1 mole of iron is the same thing as 55.85 grams of iron. Or in other words, it's 55.85 grams per 1 mole. Cool. So that's it for elements. There's our first example. When we're looking at compounds, so for elements, you literally just read it off the table, except for some of those molecular elements. So for, let's see, for compounds, all you really do is add up all the individual molar masses of every single atom that's in there. So add up all molar masses of all atoms, right? So if you add up all the things that make it up, you get the molar mass of the entire compound. So for example, if we looked for the molar mass of oxygen, you might be thinking to yourself, oh, well, what the heck is Mr. Julie talking about here? Oxygen's an element. Not the same element, not the same kind of idea as iron, though, because what does oxygen actually show up as? Oxygen shows up as O2, and it's a gas. So if I wanted the molar mass of oxygen, the molar mass of 1 oxygen atom, let's go back to the data booklet here, go to the other side. The molar mass of 1 oxygen atom is 16 grams per mole. That means the molar mass of 2 oxygen atoms must be 32 grams per mole. Perfect, so let's go back here. So the molar mass of oxygen is equal to 2 times the molar mass of an individual oxygen atom, which is 2 times 16.00 grams per mole, which is realistically 32.00 grams per mole. Now that being said, you do not need to show this much work. Not by any means when you're calculating molar mass. When I'm doing this, I literally look at my data sheet. I say, okay, I need 2 oxygens. I look at my oxygen. I say, okay, well, it's 2 times 16 is 32 grams per mole. That's the amount of work that you need to show once you get really good at this. Let's check out a couple more examples of these compounds. Let's do our next example. Let's check out something a little bit trickier. Let's look at manganese oxide. And you might be thinking something's a little funny with that title there. Is it really manganese oxide? Yeah, you might remember back. It's actually manganese 4 oxide. Manganese 4 oxide. And that might be, if you don't know where that 4 is coming from, that might be something you want to review, right? That tells us the charge of manganese is the short version of that. Cool. So let's go through and let's check this out. So the molar mass of manganese Mn oxide is equal to, so I have 1 manganese atom, the molar mass of my manganese, plus I have 2 oxygens, so 2 times the molar mass of an oxygen atom. So that is, let's check our periodic table here because I have no idea. Manganese, I think it's on the other side. Am I right? It's on the other side. Oops, wrong way. Manganese, highlighted in blue just because I'm kind of getting a little messy here. 54.94. 54.94. So 50, oh, it's still blue. 54.94 grams per mole plus 2 times mole. Start over. Plus 2 times the molar mass of oxygen, so that's 2 times 16.00 grams per mole. Excellent. And again, now I'd plug this into my calculator. Now, if you're an expert at this, if you're feeling super confident, you don't need to show all this work. You can just go straight to your calculator and your periodic table, and you can say 54.94 plus 2 times 16 is going to give me 86, and I lost the second half of it there, 86.94 grams per mole. Sweet. So let's try out 2 more real quick examples of this one. 2 more. I'm going to get that green felt pen back. I like that green felt pen. Nice. There we go. So another example. Let's do glucose. Glucose. So we know glucose is C6H12O6. Big old thing, C6H12O6. So I'm going to get out my calculator, and you know what I'm going to do with this one? Instead of writing 6 times the molar mass of carbon plus 12 times the molar mass of hydrogen plus 6 times the molar mass of oxygen, let's go straight to our periodic table. And let's first off get it so we can see everything. Maybe at this point I'll just erase and get rid of a bunch of stuff. Okay. Back to the old felt pen. So I see hydrogen. Let's see, I've got 12 hydrogens. Cool. I've got 6 carbons. So we know hydrogen is 1.01. I might write that just on the other side here. So hydrogen is 1.01 grams per mole. So let's just add them all up. Back to the old calculator. So I've got 6 times carbon. Okay, here's carbon, 12.01. This is really kind of bugging me. 6 times 12.01. Plus, let's see, I've got 12 hydrogens, so 12 times 1.01, nice, plus the last thing that I've got there is 6 oxygens, because remember it's C6H12O6, so I'm just going to go 6 times oxygen, so 6 times 16, it's going to be a big one, 180.18. 180.18 grams per mole. Nice, so that's not so bad. I'm going to do one more example, just one more example here to really drive things home. Example, let's do magnesium phosphate. So that's Mg3PO4 2. Now, usually we leave those polyatomic ions, we leave it as a single, or I guess in this case, 2 single phosphates rather than 2 phosphorus and 8 oxygen. But in this case, we actually need to add everything up. So I'm going to do the molar mass of Mg3PO4 2 is equal to, let's see, 3 times the molar mass of magnesium, because I've got 3 magnesiums, plus I've got, let's see, 2 phosphorus, so 2 times the molar mass of my phosphorus, plus, now I've got 8 oxygens, right? So 2 phosphates, each phosphate has 4, so that means 8 in total, so 8 times the molar mass of oxygen. And we're spreading it out, we're showing our work like this just to make sure that we understand everything that we've got. So when I go to my periodic table, just writing a note on my whiteboard off to the side, Mg3PO4 2. Perfect. I go to my periodic table. I got to search for these things. I got to get out my calculator. I think I made another screw up. It's got to be on this side first. So let's see. Magnesium. I need 3 magnesiums. So I'm just going to, in my calculator, let's get rid of the glucose example. I'm going to do 3 times 24.31. So 24.31, 3 times. We got 3 of them, perfect. And then I'm going to go to the other side of the periodic table and get my calculator out one more time. I'm going to add to that, so plus I need 2 phosphorus. So let's see, phosphorus, there it is, it's number 15, so 2 times 30.97 plus, and I need 8 oxygens, so 8 times 16 is a total of, holy mackerel, 262.87. 262.87 grams per mole. Cool, awesome. So one of the ways that you can practice this, if you feel like you need more practice, get any compound you feel like. You could pick off anywhere in your data booklets, whatever, any compound you feel like, and try and calculate the molar mass, and then you can honestly look up the molar mass online to check if you're right. So search molar mass of glucose. It'll come up. It'll show you the average molar mass of glucose. So no problem there. Okay. So it's one thing that we want to look at. The next thing that we want to look at in this little review piece is how to get from moles, which we always use in the chemical world, to mass, which we use in the real world, right? Because we don't have any weigh scales or electronic scales that we can just put something on and figure out, okay, well, we've got this many moles right here. But we do have scales that we can put stuff on. We've got this much mass. So we go from the chemistry world back and forth. So you may remember from Science 10, N is equal to little m over big M, where if you remember from the beginning of this lesson, little m is N is the amount measured in moles. So I'm even going to write this out. Amount measured in moles. Little m is the mass measured in grams. And then big M, we've just been working with that molar mass measured in grams per mole. Cool. So you may remember this formula. If you're choosing to use a formula, which I would not recommend doing, you need to know how to rearrange formulas. So rearranging formulas. There's a couple things you need to know. Let's see. We are always going to work in opposite functions or operations. So work in opposite operations. Anytime you want to move something, you always have to think, okay, well, I'm dividing by capital M, I got to multiply by capital M. So work in opposite operations. What we do to one side, do the same thing to the other side. So do same thing to both sides. And those are sort of the really, really, really big ideas for everything we realistically need for Chem 20. But also, the thing that we're looking for, so thing we're looking for in numerator. It needs to be a shoot. Sorry, that got kind of messy there. The thing that we're looking for needs to be in the numerator. Absolutely 100% needs to be in the numerator. So let's just go through. Let's do one real quick example of this just to kind of see, because there's two things you're typically solving for here. You're either solving for the mass or you're solving for the amount. So let's say that we had a question where we were asked to solve for the amount. Asked to solve for the amount. We're looking for n. Do I even need to rearrange this equation? No, right? We've already got it ready to go. No need to rearrange at this point. We've already got it good to go. So if we're looking for n, we've already got a recipe. N is equal to mass divided by molar mass. I just take the mass, I divide it by the molar mass. No problem. Let's look at another example. And we'll make it a little bit trickier this time. Solve for lowercase m. I'm going to be very specific that it's a lowercase m. So I go through, I start with my original, n is equal to mass divided by molar mass. Oh no, mass is not all by itself on one side of the equation. So what we have to do is we have to think, okay, well, what am I doing to mass? I'm dividing it by molar mass. So in order to move it, I need to work in opposite functions. The opposite of dividing is multiplying. So I'd go through and I'd say, okay, well, mass divided by mass, when I multiply both sides, molar mass cancels out, and I end up with mass is equal to n, or amount, times molar mass. So again, working in opposites and canceling out units where we need it. One final example that we've got here. One final example is solve for molar mass. So again, we got n is equal to mass divided by molar mass. In this case, oh no, molar mass is on the bottom. I don't want it on the denominator. So what I can do with this is, if I'm dividing by molar mass, the only way that I can move it, let's grab a different color here. Actually, let's go blue. The only way that I can move molar mass is, again, to work in opposites. So if I'm dividing my molar mass, I need to multiply both sides of the equation by molar mass. Cool. So same first step that we did there. But now, if I'm looking for molar mass, I need it all by itself. I am multiplying molar mass by amount, so I need to divide both sides of the equations by amount. And again, that's the only way you can do things. Move things, work in opposites, and do the same thing to either side. So molar mass must be equal to, let's see, mass divided by amount. Cool. So a really quick review. Again, you can check out more YouTube videos on this one if you need to. Okay, so this is one way that we can go back and forth between mass and molar mass, or sorry, mass and amount is the big thing that we're really looking at here. The other piece that we can check out with this is using our molar mass actually as a conversion factor, and this is probably the biggest thing that we want to look at, is using molar mass as a conversion factor. So for a couple examples that we've got here, let's just go through how many moles in, let's do 6.5 grams, start with an easy one, of oxygen. So things that I need to know the molar mass of oxygen, because that's what's going to get us back and forth. So the molar mass of oxygen is, we already calculated this earlier, remembering that it's O2, so I'll even put that in brackets over here. O2 is 32.00 grams per mole. Awesome, cool. And then I know that my mass is 6.5 grams, and I know that I'm looking for how many moles, so I'm looking for the amount. That's my question mark. So what I would do with this is I'd go through, and the thing that I know that only has one unit, that's what I typically want to start with. So 6.5 grams. So I'm going to say the amount is equal to 6.5 grams, And then I want to multiply this by a conversion factor. And again, if you're more comfortable, you can put 6.5 over 1. So it has a definitive top and a bottom, like a very distinctive top and a bottom. But I want to multiply this by a conversion factor. Now let's see, grams currently is on the top. If I wanted to cancel out grams, I need to put it on the bottom. Cool, excellent. I want to end up with moles. I need to put moles on the top. Now when I look back to my conversion factor, I know that it is 32 grams for every 1 mole. 32 grams for every 1 mole. So 32 has to go with the grams, and the 1 has to go with the moles. Because look, grams cancels with grams. The only unit I have left is moles, so I can get out my calculator and I can do 6.5 divided by 32, same way that we did in the last unit there, or the last lesson, I should say. 6.5 divided by 32. This is going to be equal to 0. And I've got 2 sig digs, so 0.20 moles of oxygen. Excellent. I think I've got time here for one more really quick example, one more real quick one. So let's look at one more example. So what is the mass of, let's do 6.5, no, we already did that number. Get creative here, Mr. Jukley. Of, let's do 0.98, somehow I'm back in green, 0.983 moles of, let's do K3PO4, potassium phosphate. Cool. So we're looking for the mass. That's our question mark. We are given the moles. So 0.983 moles. In order to find it, I need the molar mass. So the molar mass, let's see, K3PO4. So that's 3 potassiums. Actually, I got to go to this first. 3 potassiums. Where is potassium? There you are, 39.10. So clear, 39.1 times 3 plus, then on to the other side. Okay, what do we need here? 1 phosphorus, so 30.97, plus 4 oxygen, so 4 times 16, 212.27. 212.27. Cool, so let's go back to this one. What was it? 212.27, and of course that's grams per mole. So again, I want to start with the thing that only really has one unit. So I'm going to say my mass is equal to 0.983 moles times a conversion factor. Again, if you want to put that over 1, that's totally cool. So what needs to go in the bottom of my conversion factor? I've got moles over here. I want to cancel out moles, so I need to put moles on the bottom of my conversion factor. And then grams is going to end up going on top. So let's see, it is 1 mole for every 212.27 grams. So I see the moles cancel. I can go back to my calculator and I can do 0.983 times 212.27. And that's going to give me apparently 208.66. How many sig digs am I allowed? 3 of them. So I'm going to round that to 209 grams as my answer there. Cool. So long story short, if I just want to do a quick recap of this, and you can even try this, this might be good practice, see if you can use the formulas to get to the same thing, right? So for both of these last 2 examples, see if you can rearrange a formula and get to the same place. But what I'm going to tell you right now, it's going to be way more useful if you can think about canceling units and use this idea of unit conversion. So again, things on the top cancel with things on the bottom and make sure the numbers go in the right place. For example, it is 212.27 grams for every 1 mole, not 212 moles for every 1 gram, not the other way around. So cancel your units first and then plug your numbers in and you will always get the correct answer. So try this out. Again, you can search up other YouTube videos if you're looking for a bit more practice. Some of you are going to be aces at this right off the bat, so maybe you've done it before even. Others might have a bit of a trickier time, but you can all do this. Absolutely 100% you can all do this. So again, check out some other YouTube videos for this. Tyler DeWitt is always a good guy to check out. He's got lots of fantastic videos for Chem 20. Khan Academy is always pretty good. You could realistically just search mass to mole calculations, and somebody else will give you another idea and maybe make something click for you. Anyways, I'm going to leave it there. We'll do one more lesson where we actually put this into practice with our next step, which is just concentrations. Anyways, bye for now, Chem 20s. We'll talk again soon.